Beyond the blue dot, let us leave the solid ground behind. Close your eyes and imagine rising up past the clouds, past the layer of air that allows us to breathe, and into the great black ocean of space. Here the silence is absolute. There is no wind to brush against your face, no sound of birds or machines. There is only the endless dark, sprinkled with the cold, distant light of a billion other worlds. But if you turn around, you will see the king of our own world, the sun. From here, it does not look like the yellow circle you draw on a piece of paper. It is a terrifying, magnificent beast. It is not a solid rock, but a ball of burning gas so large that you could fit 1 million Earths inside it. It is not still. It is moving, churning and boiling. It looks like a pot of thick golden soup that never stops bubbling. It is the heart of our solar system, and right now that heart is beating fast. It is alive with fire and gravity, holding all the planets on invisible leashes as they dance around it. The season of fire, March 2025. The date is March in the year 2025. On Earth, people are worrying about taxes, traffic and the weather. They look at their phone screens unaware of the monster raging above their heads. But in space, the weather is very different. Space weather is not about rain or snow, it is about magnetism and radiation. The sun has a cycle, a rhythm like breathing. Every 11 years it wakes up. It becomes active, angry and violent. We call this the solar maximum. And in March 2025, the sun is screaming. If you could look at the surface of the sun through a special filter, you would see dark spots. These are sunspots, areas that look like bruises on the star's skin. They are the size of entire continents. These spots are places where the magnetic field's invisible rubber bands of energy are twisting and tangling. They pull tighter and tighter, storing up an unimaginable amount of energy. Suddenly, one of them snaps. This is a coronal mass ejection, often called a CME. It is a beautiful nightmare. A loop of red and orange fire larger than 10 planets erupts from the surface. It does not just glow, it roars into the silence. It throws billions of tons of superheated gas called plasma out into the void. It moves at speeds that are hard to understand, millions of miles per hour. To watch it is to see the raw power of the universe. It looks like a ribbon of light uncurling in the dark. It is beautiful, yes, but it is the kind of beauty that kills. This is the sun's fury, a storm of radiation that can cook electronics and strip away atmospheres. And right now the sun is throwing these storms out in every direction like a boxer, fighting an invisible enemy. The silent visitor, our 3-eye Atlas. While the sun rages and shouts its fears across the system, something else is moving in the dark. It is far away out past the orbit of Mars in the cold, empty space between the planets. This object is a stranger. It was not born here. It does not belong to our family of planets. Astronomers on Earth have given it a name, 3-eye Atlas. Atlas comes from the constellation Perseus, travelling for millions of years through the emptiness between the stars. It is an interstellar object, a drifter. Unlike the sun, Atlas is completely silent. It is a jagged, ugly rock, shaped like a long, broken bone. It is dark, the colour of charcoal, making it almost impossible to see against the black background of space. It is cold, frozen by the long journey through the dark. It tumbles slowly, end over end, drifting through the vacuum. It has no fire, no light, no warmth. It is a ghost. There is a deep contrast here. On one side you have the sun, massive, bright, hot and loud with electromagnetic noise. On the other side you have Atlas, small, dark, freezing and silent. The sun is the king of this castle, shouting from the throne. Atlas is the thief sneaking in through this window. Atlas does not care about the sun's anger. It is just passing through. It is moving faster than any asteroid in our system on a path that will take it close to the sun before slinging it back out into the deep universe, never to return. It is just a visitor. But timing is everything in the universe. The collision of fire and ice. As Atlas moves closest to the centre of the solar system, the sun senses the intruder. Not with eyes, but with gravity and heat. The sun prepares another attack. On the surface of the star, a massive magnetic filament becomes unstable. It has been building pressure for weeks. With a flash that would blind human eyes instantly, it explodes. This is not a normal eruption. This is a monster. A wall of plasma wide enough to swallow the moon tears away from the sun. It rushes out into the dark. It is a tsunami of fire. Atlas is in the wrong place at the wrong time. The wave of solar fire travels across the millions of miles of empty space. It moves silently, for there is no air to carry the sound of the roar. It is just a wave of pure energy and particles. Then the impact happens. It is not like two cars crashing. It is not a bang. When the solar wave hits Atlas, it is a collision of states of matter. The freezing cold surface of the interstellar rock meets the burning heat of the star. In an instant, the silence of Atlas is broken. The plasma wave slams into the rock. The violence is absolute. The surface of Atlas, which has been frozen for eons, instantly turns from solid ice and rock into gas. This process is called sublimation, but that word is too gentle for what happens here. It is an explosion of steam and dust. The dark, invisible rock suddenly lights up like a torch. The force of the solar storm pushes against it, stripping away its outer layers. Shockwaves ripple through the body of the visitor. For a moment, the tiny object glows as bright as a planet bathed in the angry radiation of the sun. The scale of this event is difficult to comprehend. To the sun, this is nothing, just a small spark in a massive fire. But for Atlas, it is a catastrophe. The visitor shudders under the blow. Its trajectory, the path it was travelling, shifts ever so slightly. It is a small push, a tiny nudge in the vastness of space. But in the delicate dance of celestial mechanics, a small nudge can change destiny. The silent visitor has been woken up. It's no longer just a rock drifting in the dark, now it is bleeding gas and dust leaving a trail behind it. It has been slapped by the hand of the star. And as the wave of fire passes, continuing its journey outward toward the planets, Atlas continues its tumble. But something has changed. The heat has awakened something deep inside the rock, something that has been sleeping for 1 billion years. The sun's fury has greeted the traveller, and the traveller is about to answer. The dust from the first collision had not even fully settled in the vacuum of space before the universe decided to test us again. The scientific community was still holding its collective breath, staring at the screens waiting for the telemetry data to make sense. We expected 3i Atlas to wobble. We expected it to spin. We expected a cloud of debris, but before we could even process the lack of reaction from the first hit, the second impactor arrived. It was a chaotic piece of space junk, a jagged rock roughly the size of a small house, trailing behind the first one like a younger, clumsier sibling. In any other astronomical event, this would be a headline all on its own. But here it was merely the second bullet in a cosmic firing squad. The second collision was not a glancing blow, it was rapid, it was violent. The rock slammed into the midsection of 3i Atlas with a ferocity that should have shattered both objects into 1 million glowing shards. On our thermal imaging screens, the point of impact flared white-hot, a sudden bloom of violent energy that blinded our senses for a fraction of a second. Then came the third. It happened so fast that the human eye could not follow it in real time. We only saw it in the slow-motion replay later. A third asteroid, smaller than the second, but travelling much faster, struck the upper quadrant of the dark object. It was a rapid-fire assault, a 1-2-3 punch that seemed statistically impossible. In the vast, empty ocean of space, the chances of a single object being hit by 3 separate asteroids in the span of a few hours are so low that the number involves more zeros than a human brain can comfortably imagine. It was not just unlucky, it felt targeted. It felt like the universe was angry at this intruder. But the true horror was not in the violence of the impacts. The horror was in what happened next, or rather, what did not happen. To understand why every physicist in every observatory felt a cold shiver run down their spine, we have to talk about the most basic rules of our reality. We have to talk about Isaac Newton. Hundreds of years ago, Newton gave us a law that governs everything from apples falling from trees to planets orbiting stars. It is simple: for every action there is an equal and opposite reaction. This is the law of conservation of momentum. Think of a game of billiards. When the white cue ball hits a coloured ball, the white ball slows down and the coloured ball moves away. Energy is transferred. The motion passes from one object to another. If you run full speeds into a wall, you bounce back and the wall vibrates. If a car crashes into a truck, metal crunches, glass shatters, and both vehicles skid across the road. Energy cannot just disappear. It has to go somewhere. It becomes heat, it becomes sound, it becomes motion. This is the law. It is not a suggestion. It is the fundamental architecture of existence. And yet 3i Atlas ignored it. When the second and third rocks slammed into it, 3i Atlas did not move. It did not slow down by even 1 meter per second. It did not speed up. It did not tilt by a single degree. It did not spin. The dust and debris from the asteroids that hit it splashed against its surface like water hitting a pane of glass, then drifted away into the dark. But the object itself, it simply continued on its path, cruising at exactly the same speed on exactly the same line. Imagine throwing a tennis ball at a moving freight train. The train does not care. It keeps moving. That makes sense because the train is huge and the ball is small, but this was different. This was like throwing a bowling ball at another bowling ball and having the second one not even wobble. The kinetic energy, the sheer force of those impacts was massive. That energy should have pushed 3i Atlas off course. It should have caused the object to tumble end over end. At the very least, it should have created a massive crater or a crack in the surface. But the telemetry data remained a flat, stubborn line. Speed constant, trajectory constant, structural integrity 100%. In the control rooms of the world's great observatories, from the high peaks of the Andes Mountains in Chile to the volcanic summits of Hawaii, the initial confusion began to curdle into a deep, quiet fear. At first, the scientists thought the equipment was broken. You could see them in the live streams and the internal video feeds. Men and women with PhDs, people who had studied the stars for decades, were tapping their computer screens and checking the cables. They were rebooting their systems. They were calling their colleagues on the other side of the world, asking, "Are you seeing this? Is my sensor calibrating correctly?" "It must be a glitch," one astronomer in the Canary Islands muttered, rubbing his tired eyes. "The radar is showing 0 deviation. That is impossible. Reset the tracking algorithm." But the algorithm was fine. The radar was working perfectly. As the data was confirmed by station after station, the mood shifted. The frantic typing stopped. The room noise dropped from a busy hum to a heavy silence. People stopped drinking their coffee. They stood up from their chairs and just stared at the main projection screens. They were witnessing a violation of nature. If an object does not move when you push it, it means one of two things. Either it is infinitely heavy, so heavy that a mountain smashing into it feels like a feather, or it has some way to absorb and cancel out the energy that we do not understand. Neither option was comforting. If 3i Atlas was that heavy, its gravity should have been tearing the nearby asteroids apart before they even hit. But it wasn't. Its gravity signature was normal. That left the second option: it was absorbing the blow. It was taking the punch and eating the energy. The visual feed from the Hubble successor telescope gave us the clearest picture yet. We zoomed in looking for the scars. We looked for the craters where the second and third asteroids had hit. There were none. The surface of 3i Atlas was a dark matte charcoal colour. It looked smooth, almost like manufactured metal, but with the texture of ancient stone. Where the impacts had occurred, there was no dent. There was no scratch. There was not even a smudge. The asteroids had pulverized themselves against it, turning into dust, but the object remained pristine. It was a perfection that felt wrong. In nature, things are messy, rocks are chipped, comets are lumpy, moons have craters. Everything in the universe carries the scars of its history. To survive billions of years in the void of space means you get beat up. You get scratched. 3i Atlas looked like it had been made yesterday. I remember an old professor of mine describing the solar system as a chaotic, violent river. He said that asteroids and comets are like driftwood tossing and turning, caught in the currents of gravity, smashing into each other, breaking apart, constantly changing. If the solar system is a raging river, 3i Atlas was not driftwood, it was a stone. It was a heavy, immovable, ancient stone sitting in the middle of a flash flood. The water raged around it, debris slammed into it. The current tried to push it, but the stone did not care. It forced the river to move around it. This absolute stability was terrifying. It suggested that the object was not just a visitor, it suggested intent. A rock drifting through space is at the mercy of physics. But something that takes a hit and doesn't move, that implies control, that implies that its path was not accidental. It was going exactly where it wanted to go, and nothing, not a rock, not a collision, perhaps not even a nuclear weapon, was going to push it aside. The silence from the object was louder than any radio signal. We were listening for beeps, for clicks, for a message in binary code. We wanted it to say hello. Instead, it gave us this physical silence. It gave us the silence of a tank rolling over a barricade without slowing down. We watched as the cloud of dust from the third impact slowly dissipated, drifting off into the blackness. 3i Atlas emerged from the cloud, dark and terrible and beautiful. It reflected the weak sunlight with a dull, indifferent sheen. It was close now. It was passing the orbit of Mars. The time for curiosity was ending. The time for worry had begun. The physics textbook said this was impossible. The sensors said it was real. And as we watched that impossible trajectory, a single unified thought began to form in the minds of every person watching the screens. It is not stopping. It is not turning. And it is looking right at us. The silence that followed the third impact was not empty. It was heavy, like the air in a room just before a thunderstorm breaks. For a few agonizing minutes, the data streams returning from the probe showed nothing but the standard background noise of the solar wind. We watched the monitors, holding our breath, waiting for the star to settle back into its chaotic, indifferent rhythm. We expected the ripples to fade. We expected the sun to treat our probe like a piece of dust consumed and forgotten. But the sun did not forget. Up until this moment, we'd been firing at a sleeping giant. The first 3 kinetic strikes were mosquito bites on the skin of a bear. But with the third strike, something fundamental shifted deep within the stellar atmosphere. The random bubbling noise of the photosphere, the visible surface of the sun, began to change. It was no longer random. The reaction of the sun was not immediate, but it was terrifyingly deliberate. The telemetry showed a sudden drop in temperature across a vast area of the northern hemisphere, followed instantly by a spike in magnetic pressure. In simple terms, the star was taking a breath. This is where the true dialogue of titans began. The sun was no longer a passive background for our experiment. It was becoming an active participant. The Great Restructuring. On the main viewing screen, the image of the sun was filtered to show magnetic field lines. Usually these look like tangled hair, messy, chaotic, and looping everywhere without a clear pattern. But now, right before our eyes, the chaos began to order itself. The magnetic field started to twist. It was a slow grinding movement, like massive ropes being tightened by an invisible winch. We watched as the loose loops of plasma snapped together, fusing into tight, high-tension bundles. This process is what we usually call magnetic reconnection, but the scale and speed were impossible. It looked less like physics and more like biology. It looked like muscle fibers contracting. The active regions, those bright, violent areas on the sun where sunspots usually form, began to flare up in unison. It was not a chain reaction where one triggered another. They all brightened simultaneously. It felt as though the sun was opening 1,000 eyes at once. One specific region, located directly beneath the probe's calculated trajectory, underwent a transformation that made the hair on our arms stand up. The sunspots' usually dark, irregular shapes shifted. They circled each other and merged, forming a perfectly round dark abyss, surrounded by a ring of blinding white fire. To everyone in the control room, the resemblance was undeniable. It looked exactly like a dilated pupil. The star was staring back. The probe was a tiny speck of metal and ceramic, invisible against the backdrop of space. Yet the sun seemed to know exactly where it was. The magnetic field lines around this eye reached out not randomly, but stretching toward the vacuum where our machine was drifting. It was a sensation of being watched by something so large that the human mind struggled to comprehend it. The active regions were no longer just storms of gas. They were sensory organs bearing their nerves to the cold of space to locate the intruder. The fourth strike aiming for the future. The mission plan called for a fourth kinetic strike. The probe was programmed to release a tungsten rod accelerated to a fraction of the speed of light to pierce the upper corona. In our simulations, this was the simple ballistic calculation. We fire the shot, the sun absorbs it, we measure the splash. But the sun had changed the rules. As the probe prepared its firing solution, the star moved first. Deep within the pupil of the active region, a massive accumulation of energy occurred. We saw the readings for X-ray flux climb vertically. The energy did not disperse, it concentrated. It held itself in check building pressure, waiting. Then the probe released its payload. At the exact moment the tungsten rod left the launch rail, the sun released a coronal mass ejection CME. But this was not a normal explosion. Usually a CME expands outward like a shotgun blast, messy and wide. This one was different. It was a spear. A concentrated jet of superheated plasma moving at over 2,000 kilometers per second shot out from the surface. What froze the blood in our veins was the trajectory. The sun did not fire at the probe, it did not fire at where the probe was. The sun fired at where the probe was going to be. It was a masterclass in interception. To hit a moving target in space, you must lead your shot. You have to calculate the speed of the target, the distance, and the travel time of your own projectile. You have to predict the future position of the enemy. The solar jet intersected the tungsten rod 400 kilometers away from the probe. The collision was absolute. The rod was vaporized instantly, turned into a cloud of metallic gas before it could even get close to the surface. The plasma jet continued onward, passing within a hair's breadth of the probe itself, rocking it violently with the shockwave of charged particles. It was a warning shot. A silence fell over the control room that was far deeper than the one before. We were all mathematicians and physicists. We understood probability. The chances of a random solar flare occurring at the exact second of our launch and happening to be aimed exactly at the future trajectory of our payload were 1 in billions. It was statistically impossible. This meant the alternative was true. The sun had sensed the buildup of energy in the probe, calculated the threat, and neutralized it with the precision of a sniper. Contemplation machine or monster. The data coming in was now irrelevant. No one cared about the chemical composition of the corona anymore. The question on everyone's mind had shifted from astrophysics to philosophy. We watched the screens as the sun settled back down, the pupil slowly dissolving back into a messy cluster of sunspots. The magnetic ropes loosened, the muscles relaxed, but the feeling of dread remained. We had to ask ourselves, what are we looking at? For centuries we have viewed the sun as a nuclear furnace, a glorious complex machine governed by gravity and fusion. We believed that if we understood the math, we understood the star. We thought it was a lifeless engine burning fuel until it died. But engines do not react to threats. Engines do not anticipate the future. The behavior we witnessed suggested a feedback loop so complex that it mimicked intelligence. The electromagnetic fields of the sun connect every part of the star to every other part. It is a web of energy larger than 1,000,000 Earths. Is it possible that this web acts like a neural network? Is it possible that the plasma flows are not just gas but information? When the probe struck the first 3 times, perhaps it was like a fly landing on a sleeping man. He twitches, he swats blindly, but the 4th time the man wakes up, he sees the fly, he waits for it to move and he strikes. This leads to a chilling realization about the scale of consciousness. We look for life that looks like us, biological, wet, carbon-based. We look for signals in radio waves, but maybe we have been standing next to a living entity for our entire history, unable to recognize it, because its heartbeat takes 11 years to cycle and its thoughts are made of magnetic fire. The dialogue of Titans was not a conversation between equals. It was a brief moment where a microbe shouted at a god and the god turned its head to look. As we prepared to abort the mission and pull the probe back, the sun released one final pulse of radio static. It wasn't a flare. It wasn't an attack. It was a low rhythmic thrumming that vibrated through every sensor we had. It sounded like a purr or perhaps a growl. We had gone looking for data. Instead, we found a boundary. We had poked the beast and the beast had shown us that it was not a blind machine. It was watching. And now we knew that while we depend on its light to survive, we are merely guests in its house. And guests should be careful not to overstay their welcome. The probe turned its engines toward the dark, fleeing the light, leaving the Titan to its thoughts. We would not strike a 5th time. The physics of impossible survival. To truly understand why this object is so terrifying to the scientific community, we must stop looking at its shape and start looking at where it is parking. We need to talk about heat. We are not talking about the heat of a desert at noon, or even the heat inside a steel factory's blast furnace. We are talking about the environment of the solar corona. The atmosphere of the sun is a place of violent contradictions that has puzzled physicists for a century. Logic suggests that as you move away from a fire, the air should get cooler. But the sun defies this simple logic. The visible surface of the sun, the part we see, is roughly 5,500 degrees Celsius. However, if you move outward away from the surface and into the halo of ghostly plasma surrounding the star, the corona, the temperature does not drop. It skyrockets. It jumps to over 1,000,000 degrees Celsius. This is the environment where our mystery object is hovering. By all known laws of material science, any solid object placed in this zone should not exist. It should not just melt, it should vanish. It should be instantly ripped apart atom by atom and turned into a cloud of superheated vapor. Even the most heat-resistant materials humanity has ever engineered, like complex ceramics or tungsten alloys, begin to turn into liquid at around 3,000 or 4,000 degrees Celsius. That is barely a fraction of the temperature found in the corona. So how is it surviving? If we strip away the magic of science fiction and look at this through the lens of simplified physics, we are left with 2 primary possibilities. Both of them suggest engineering capabilities that are so advanced they might as well be magic. The thermal hypothesis, the miracle of dispersion. The first scientific possibility is that the object is made of solid matter, but matter that behaves in a way that violates our current understanding of heat transfer. This brings us to the thermal hypothesis. To understand this, imagine you are holding a long iron rod. If you stick one end of that rod into a campfire, the tip gets red hot almost immediately. However, the end you are holding remains cool for a minute or 2. This happens because heat takes time to travel through the metal. This property is called thermal conductivity. In almost all materials found in nature, heat concentrates at the point of contact before it spreads out. If the heat is intense enough, that specific point will melt or burn before the rest of the bar even gets warm. Now imagine a material where thermal conductivity is effectively infinite. If this massive black sphere were constructed from such a super material, the physics of heating would change completely. The moment the 1,000,000-degree solar plasma touched the hull of the ship, that heat energy would not stay in one spot. It would instantly flash across the entire surface area of the massive sphere. Instead of one spot heating up to 1,000,000 degrees and burning a hole through the ship, the entire ship would warm up uniformly but to a much lower manageable temperature. Think of it like a drop of red dye. If you drop it into a shot glass, the water turns deep red instantly. But if you drop that same amount of dye into a massive Olympic-sized swimming pool, the colour disappears. The dye is still there, but it is so spread out that you cannot see it. The volume of the water dilutes the dye. This object is the size of a planet. If it possesses a hull that can disperse energy with zero resistance, it turns the deadly localized heat of the sun into a gentle, spread-out warmth. It effectively dilutes the fire of the sun across its massive body. To build such a hull, a civilization would need to master atomic structures far beyond our current grasp. They would need a material that does not expand, warp, or crack when shocked by heat. It suggests a mastery of the strong nuclear force, the glue that holds atoms together, allowing them to create a shell that is virtually indestructible because it refuses to let energy accumulate in any single weak point. The magnetic hypothesis, the bubble in the ocean. The second theory is perhaps even more compelling because it relies on the nature of the sun itself. We often think of the sun as fire, but it is not fire in the traditional sense. It is plasma. Plasma is the fourth state of matter. It is a soup of superheated gas where the atoms have been ripped apart. Because the electrons are ripped away, solar matter is electrically charged, and because it is electrically charged, it is a slave to magnetism. This is where the invisible shield comes into play. If you take two powerful magnets and try to push their north poles together, you feel a cushion of invisible resistance. They refuse to touch. The harder you push, the harder the invisible force pushes back. Now scale that up to a cosmic level. Imagine this black sphere is not actually touching the solar plasma at all. Instead, it is generating a magnetic field of colossal proportions, a magnetosphere, similar to the one that protects the Earth from solar radiation, but condensed and amplified millions of times over. In this scenario, the object is wrapped in a magnetic bubble. As the 1,000,000-degree plasma crashes toward the ship, the magnetic field deflects the charged particles. It forces the plasma to flow around the object like water, flowing around a smooth stone in a river. The heat never actually touches the physical hull. The object sits in a pocket of magnetic vacuum, a calm eye in the center of a fiery storm. This explains the visual darkness of the object perfectly. If it is deflecting the solar plasma, it is creating a void where the light and heat of the sun cannot enter. It appears as a hole in the sun because it is literally pushing the sun away. However, the energy required to do this is staggering. To generate a magnetic field strong enough to push back the crushing pressure and density of the sun's atmosphere would require energy output equivalent to thousands of nuclear power plants running at full capacity, all focused into a shield generator. It implies a power source inside that ship that rivals the output of a small moon. The engineering of thermodynamics. Whether they are using a heat-dispersing hull or a magnetic shield, we are forced to admire the sheer engineering audacity of it. But there is one final hurdle: the laws of thermodynamics. In physics, the second law of thermodynamics is particularly stubborn. It states that heat always flows from a hot object to a cold object until they are equal. You cannot cheat heat forever. Even with a magnetic shield, the infrared radiation, the pure light heat, would eventually cook the ship. Eventually, the inside should become an oven. For a civilization to park a ship here, they must have solved thermodynamics. They are likely not just blocking heat, they are converting it. This is the most frightening thought of all. What if they are not just surviving the heat? What if they are eating it? A civilization capable of this might view the 1,000,000-degree corona not as a danger, but as a fuel station. The intense thermal energy hitting their shields could be captured, converted into electricity, and used to power the very shields that protect them. It creates a perfect self-sustaining loop. The hotter the sun burns, the stronger their shields become, and the more energy they have to harvest whatever they are taking from the star. This level of technology implies a Type 2 civilization on the Kardashev scale, a society that has graduated from burning dead plants and splitting atoms to harnessing the total energy of a star. To them, our physics problems are likely elementary school puzzles. They do not fight nature, they domesticate it. They have turned the most hostile environment in the solar system into a comfortable parking lot. This invisible shield tells us that whoever built this does not fear the sun. They respect it, they understand it, and they have completely conquered the dangers it presents. While we look at the sun and see a nuclear bomb that sustains life from a safe distance of 93 million miles, they look at the sun and see a campfire they can sit right next to without ever getting burned. The universe does not always shout. Mostly it mumbles. In the vast, dark ocean of space, we are usually looking for a lighthouse beam. a bright flash that says I am here. But the reality of the cosmos is far more subtle. It was late on a Tuesday when the anomaly appeared buried deep within the static of our local star. It was not a shout. It was barely a whisper hidden inside the roaring winds of the sun. This specific piece of data centered around a very special frequency 1.42 GHz. To the average person, this number might seem random. But to an astronomer, 1.42 GHz is the song of hydrogen. Hydrogen is the most common element in the universe. It is the building block of stars and water. Many scientists have believed for decades that if an intelligent civilization wanted to say hello, they would use this frequency. It is a universal meeting point, a waterhole where different species might meet in the radio spectrum. The signal we found was terrifyingly brief. It lasted for only 0.7 seconds. It did not repeat. It did not have a complex pattern of prime numbers or a map of the stars. It was a simple, sharp rise in intensity, a sudden spike that stood out against the chaotic background radiation of the solar wind. If the background noise of the universe is like the sound of rain falling on a tin roof, this signal was like a single soft note played on a flute heard for just a heartbeat before the rain drowned it out again. It was fragile. It felt like a sigh, a digital breath exhaled across the emptiness of the void. The world of the scientists. In the movies, a discovery like this leads to immediate press conferences, champagne and breaking news. In the real world, the reaction is silence. A strange phenomenon occurs in the scientific community when data like this is found. It creates a parallel world of information, something we call shadow literature. Standard science relies on peer review. You write a paper, you send it to a journal, experts check it, and then it is published for the world to see. That process takes months, but the 1.42 GHz signal was too hot, too dangerous, and too uncertain for that process. Instead, it lived in the shadows. It existed in drafted emails that were never sent. It lived in secure chat rooms and private servers. It was discussed in hushed tones during coffee breaks at conferences where one researcher would lean in and ask another, "Did you see the raw data from the solar observatory from last Tuesday?" The excitement was there, but it was suffocated by fear. No one wanted to be the person who claimed to find aliens only to discover it was actually a microwave oven in the break room or a glitch in the satellite software. This has happened before and the embarrassment lingers for a career. So the reports were written, but they were marked internal use only. They were leaked cautiously between friends at different observatories. This shadow literature was fascinating. It contained wild theories and hopeful mathematics that no one dared to put their name on publicly. In these secret documents, the tone was not clinical, it was emotional. One leaked memo described the signal not as data, but as a ghost. Another senior astronomer wrote in a private journal that the signal felt intentional, as if someone had aimed a laser pointer at our eye for a split second and then turned it off. They argued about the Doppler shift. Because the Earth is moving and the source of the signal is likely moving, the frequency of the radio wave changes slightly. By measuring this change, we can tell how fast the object is moving. The shadow reports suggested the source was not orbiting a star, but was moving through the deep space between stars drifting alone. But they could not prove it. The excitement remained trapped behind closed doors, a secret kept by a few hundred people who looked at the sky with a mixture of wonder and terror. The deficit of data. The tragedy of this event was not that we couldn't hear it, but that we couldn't hear enough of it. This brings us to the painful concept of the data deficit. We like to think we are watching the sky with eagle eyes. We imagine we have telescopes pointing everywhere all the time. The truth is much more humbling. We are looking at the universe through a drinking straw. We can only look at a tiny patch of the sky at one time. We can only listen to a few radio frequencies at once. The 1.42 GHz signal was caught by pure luck. A telescope happened to be calibrating pointing near the sun at the exact moment the signal arrived. If the signal had arrived 10 seconds later, the telescope would have moved. If the signal had been 5 MHz higher, our filters would have ignored it as noise. This creates a profound sense of loss. How many whispers have we missed? How many civilizations have shouted hello while we were looking in the other direction? The data we have is a single pixel in a massive image. We are trying to reconstruct a face, but we only have a picture of an eyelash. The shadow literature was filled with requests for more telescope time, desperate pleas to turn the giant ears of the Earth back toward that spot in the solar wind. But the solar wind is turbulent. It is like trying to hear a whisper in a hurricane. The moment had passed. The geometry of the planets had shifted. The source, whatever it was, had gone silent, or we had simply lost the thread. We were left with a one-point datum. In science, a single data point is a nightmare. You cannot draw a line with one dot. You cannot prove a trend. You can only stare at it and wonder. It sits there mocking you, neither confirming nor denying the existence of life beyond Earth. Reflections on the silence. This brings us to a deep philosophical reflection. We are creatures who crave meaning. When we see a cloud, we look for shapes of animals. When we hear a noise in the night, we imagine a story. The silence that followed the signal was heavy. It forced us to confront the possibility that the universe is not empty, but it is incredibly shy. Maybe we are thinking about this wrong. We expect other civilizations to be like us, noisy, messy, constantly broadcasting our television shows and radar signals into space. But what if advanced life is quiet? What if they have moved past the need for high-power radio transmissions? Or perhaps the signal was a beacon, a lighthouse that spins once every 100 years. We just happened to catch the flash. To see it again, we might have to wait a lifetime. There is a poetic sadness in the 1.42 GHz signal. It represents the friction between our desire to know and the limits of our technology. We are standing on the shore of a boundless ocean holding a small cup. We dipped the cup in and caught a single shining fish. But before we could study it, it slipped back into the water. Now we stand on the shore and wait. We improve our nets. We build bigger cups. We argue in quiet rooms about whether the fish was real or a trick of the light. The solar wind continues to blow against the magnetic field of the Earth. It creates auroras, beautiful lights in the northern sky. But hidden inside that wind, masked by the radiation of our own star, there might be other messages. We learned that the universe is speaking. It is just not speaking to us directly. We are overhearing a conversation we do not understand, catching a fragment of a sentence spoken in a language of pure mathematics. The signal was short, it was fragile, but it changed everything. It proved that the silence of space is not total. It is merely waiting for us to learn how to listen better. The whisper is there, drifting through the vacuum, waiting for the next time we turn our heads at exactly the right moment. We must now confront the most uncomfortable part of this mystery. When we strip away the impossible, whatever remains, however improbable, must be the truth. To understand what this visitor was, we first have to rigorously understand what it was not. For months, astronomers desperately tried to fit this object into boxes we already understood. The most obvious box was that of a comet. Comets are the icy wanderers of our star system. When they get close to the sun, the heat boils their ice into gas, creating a visible tail. This process, called outgassing, acts like a natural rocket engine. The gas shoots out one way and the rock gets a push in the other direction. This would explain the strange extra speed the object gained as it left our solar system. It is a standard natural explanation. However, the data simply refused to cooperate with this theory. Deep space telescopes looked for a tail. They looked for carbon-based molecules, for water vapor, for dust. They found nothing. The object was completely dry. There was no coma, no cloud of gas surrounding it. If it were a comet large enough to generate that much speed through outgassing, it would have lost about 1/10 of its total mass in the process. That is a violent event. It would have been bright and impossible to miss. Yet the object remained dark and silent. Then came the exotic natural theories. Some scientists proposed it was a hydrogen iceberg, a chunk of frozen hydrogen formed in the heart of a giant molecular cloud. This would explain why we did not see a tail. Pure hydrogen gas is invisible to our senses. But this theory fell apart under the scrutiny of basic thermodynamics. A block of frozen hydrogen would have evaporated long before it ever reached our solar system, simply from the ambient light of the stars during its millions of years of travel. It would have vanished like an ice cube on a hot sidewalk. Others suggested it was a shard of a destroyed planet or a piece of a neutron star crust, but the motion was all wrong. A piece of debris tumbles randomly, obeying only the pull of gravity. This object did not just fall, it seemed to push back. The way it reflected light suggested it was 10 times more shiny than a typical asteroid, closer to polished metal than space rock. Every natural explanation required us to invent a new type of physics or a never-before-seen material. So we must pivot. We must look at the behavior not as a random accident, but as a choice. Let us move to the concept of the testing hypothesis. To understand this, you must stop thinking like a human astronomer and start thinking like an interstellar probe. Imagine you are an artificial intelligence, a machine built by a civilization thousands of light years away. Your mission is to map the galaxy and look for signs of life or technology. You're not biological, you have infinite patience. You drift through the darkness between stars for millennia. When you finally approach a star system like ours, a yellow dwarf star with stable planets, what is your protocol? Do you simply fly by in a straight line? No. That yields very little data. To truly understand a system, you must interact with it. You need to perform a stress test. The trajectory of the object took it on a very specific path. It dropped from the galactic north, cutting through the plane of our solar system at a sharp angle. It dove extremely close to the Sun, closer than the planet Mercury. This is a slingshot maneuver. In orbital mechanics, this is how you gain speed or change direction without using fuel. But for a probe, this is also the perfect way to scan the entire neighbourhood. By diving that close to the Sun, the object placed itself in the region of highest energy and highest visibility. If there is an intelligent civilization in that star system, they will be watching their sun. By skimming the surface of the star, the probe ensures it will be backlit, creating a silhouette against the solar plasma. It is effectively ringing the doorbell. If you were that machine, you would then accelerate on your way out. This acceleration is the test. A dumb rock follows a predictable curve calculated by Isaac Newton 300 years ago. A smart machine changes its speed. It breaks the curve. By accelerating in a non-gravitational way, the probe is offering a puzzle to the locals. It is asking, do your sensors work? Do you understand physics? Can you see that I am not behaving like a rock? If we, the observers on Earth, notice the anomaly, we have passed the first stage of the test. If we had ignored it, we would have been categorized as unintelligent or technologically primitive. This leads us to the fascinating concept of hidden intelligence. In science fiction, alien ships are often portrayed as massive glowing cities with humming engines and bright lights. But in reality, that is a waste of energy. A true interstellar probe would prioritize survival and stealth. The smartest way to travel the galaxy is to look like debris. Consider the rotation of the object. As it moved away from us, its brightness dimmed and brightened every 8 hours. This told us it was tumbling. It was not spinning smoothly like a top, it was flipping end over end. At first glance, this looks like chaos. It looks like a dead rock that has been hit by something. But consider the advantage of this tumble for a machine. If you are a probe, you need to scan in all directions. If you are stabilized and pointing just one way, you have blind spots. By tumbling, your sensors sweep the entire sky every few hours. Furthermore, the tumbling creates a thermal balance. It prevents one side of the ship from boiling while the other side freezes. The genius of this design is that it acts as camouflage. To a primitive observer, a tumbling object looks uncontrolled. It looks natural. It is the ultimate disguise, feigning incompetence. It is the cosmic equivalent of a spy playing dead. It allows the probe to gather information without triggering a threat response from the civilization it is observing. It was only when our mathematicians analysed the trajectory that we realised the dead rock was moving with a purpose that defied its appearance. Finally, we must look at the connection, the invisible link between the object and our sun. If there was no engine burning fuel, where did the power come from? The most robust scientific theory that fits the data is that the object was a light sail. This is a technology we humans are currently developing. It involves using a thin reflective surface to catch the pressure of light, just as a boat catches the wind. Photons, the particles of light, have no mass, but they do have momentum. When they bounce off a reflective surface, they impart a tiny push. Over vast distances, this tiny push can accelerate a spacecraft to incredible speeds. The object accelerated as it moved away from the sun. The force that pushed it dropped off exactly in proportion to the intensity of the sunlight. As the sunlight got weaker, the push got weaker. This mathematical correlation is the smoking gun. It suggests the object was perfectly designed to harness the power of our star. This creates a profound relationship. The object was not just a visitor, it was a parasite of our sun's energy. It used the sun to break upon arrival, and it used the sun to accelerate upon departure. But there is a deeper layer to this connection. In radio technology, we use carrier waves. We modulate energy to send data. If this object was a solar sail, its surface was interacting with the sun's electromagnetic field on a massive scale. Is it possible that the push was not just propulsion, but communication? By reflecting the sunlight so precisely, could it have been directing a beam of energy back towards where it came from? Or perhaps it was absorbing data. The sun is constantly emitting a stream of particles, the solar wind that contains the history of our system's chemistry. By dipping into this stream, the object tasted our star. It sampled the isotopes and the magnetic fields. In this light, the object was not an invader or a monster. It was a scientist. It came, it tested us, it gathered its data, and it left. It treated the sun not just as a gravity well, but as a battery and a library. And in its wake, it left us with the stranger's test, a test of our curiosity. Did we just see a rock, or did we see the reflection of a higher intelligence in the mirror of our own telescopes? The answer depends entirely on whether we are brave enough to admit that we might not be alone. When we look up at the night sky, we usually feel a sense of overwhelming emptiness. We see the stars as distant burning fires separated by oceans of silence. We often think of the search for extraterrestrial intelligence as an active pursuit, us reaching out, us listening, us scanning the void for a signal that travelled across the galaxy to find us. But there is another possibility, a perspective that shifts the camera angle entirely. What if the search is already over? What if we are not the hunters, but the ones who have already been found? This brings us to a fascinating concept proposed by a scientist named Ronald Bracewell in 1960. While everyone else was obsessed with listening for radio signals, Bracewell asked a simple, practical question. If you wanted to study a beetle in the Amazon rainforest, would you stand on a mountain in Europe and shout at it? No, you would go there. You would send a camera, you would send a drone, you would place a sensor on a tree and wait. Radio waves are fast travelling at the speed of light, but they have a weakness. They get weaker the farther they travel. They scatter and fade into the background noise of the universe. But a physical object, a machine, a probe is solid. It is patient. This is the Bracewell probe hypothesis. It suggests that an advanced civilization would not waste energy beaming radio messages into the void, hoping someone hears them. Instead, they would send out thousands, perhaps millions of automated probes to every star system that looks promising. Imagine a machine no larger than a car built with technology we cannot yet understand. It was launched millions of years ago from a star system far away. It travelled through the cold, dark spaces between stars, moving quietly, powered by the energy of the stars it passed. It does not need to rush. It does not get bored. It does not die. Its mission is simply to arrive to park itself in a stable orbit, perhaps hidden inside an asteroid or lurking in the dark spaces behind the moon, and wait. It might have arrived here 1 billion years ago. It would have seen the Earth when it was just a green and blue ball of simple life. It saw the dinosaurs rise and fall. It watched the continents drift apart and crash back together. And then in the blink of an eye, which is what human history feels like to a machine that lives forever, it saw the lights turn on. It detected our first radio broadcasts. It saw our cities glowing at night. It saw us leave our own atmosphere. This idea changes our entire view of the universe. It creates the feeling of the cosmic fishbowl. Think about how we treat rare animals in a nature reserve. We do not interfere with them. We do not land a helicopter in the middle of a herd of zebras and start shaking hands. We place cameras in the grass. We fly drones high above. We watch them on screens, gathering data, learning how they behave, how they eat, and how they interact. We are the observers, they are the observed. To the fish in the aquarium, the glass walls are the end of the universe. They do not know that outside the glass, there is a room, and in that room, there are faces pressing against the glass, watching with curiosity. In this scenario, the Earth is the fishbowl. The dark boundary of our solar system is the glass, and the Bracewell probes are the cameras hidden in the gravel recording everything we do. For many people, this thought might be terrifying. We are used to being the masters of our domain. We are the apex predators, the explorers, the conquerors. To think that there are ancient devices floating in the dark monitoring our internet, listening to our phone calls and measuring our carbon emissions makes us feel small. It strips away our feeling of control. It forces a deep, sometimes uncomfortable humility upon us. However, this humility is necessary. It corrects our vision. For thousands of years, humans believed the Earth was the center of the universe. Then we learned we orbit the Sun. Then we learned the Sun is just one average star among hundreds of billions. Now we must accept that even our civilization with all our art, science and wars might just be a single entry in a galactic encyclopedia. We are a data point. To the intelligence that built the probe, we are likely not special in the way we think we are. We are not the heroes of the galaxy's story. We are simply emerging civilization number 4022. They are watching to see if we survive our own technology. They are watching to see if we destroy our climate or if we learn to balance our energy use. They are watching to see if we stop fighting each other long enough to travel to the stars. We are a case study in evolution. The probe is likely recording our music, our languages, and our biological data, transmitting it back to a central network via a laser beam, or a method of communication we haven't discovered yet. But here is where the feeling shifts. It shifts from the fear of being watched to the awe of being known. If the Bracewell hypothesis is true, it means something wonderful. We are not alone. We have never been alone. The silence of the night sky is not because it is empty. It is silent because the observers are polite. They are like librarians in a great reading room, moving quietly so as not to disturb the readers. There is a profound comfort in this thought. It means that our existence is being remembered. Even if humanity makes a terrible mistake and destroys itself tomorrow, our story has been backed up. The probe has seen us. It has recorded Shakespeare and the Beatles. It has recorded the sound of rain in the rainforest and the laughter of children. It has sent that data into a galactic network, a library of life that spans the Milky Way. We become part of a much larger tapestry. We are connected to a network of knowledge that is millions of years old. We are not isolated on a lonely rock drifting in nowhere. We are a node in a vast system. This changes how we walk under the stars. When you stand in a dark field and look up at the Milky Way, you're not looking into a void. You're looking into a populated room where the lights have been dimmed. You're looking at the lenses of 1,000 cameras held by the hands of a civilization that solved the problems we are currently facing. It replaces the fear of the unknown with a sense of kinship. The silence is not indifference. It is patience. They are waiting for us to grow up. They are waiting for us to tap on the glass of the fishbowl, not with aggression, but with understanding. They are waiting for the moment when we are ready to look at the camera and say, "We know you are there. We are ready to join the conversation." So the eyes in the dark are not the eyes of monsters. They are the eyes of history. They are the keepers of the archive. And realizing they might be there, floating silently in the gravitational shadows of our solar system, gives us a responsibility. It compels us to be a civilization worth watching. It encourages us to act as if our actions matter not just to ourselves, but to the galactic record. In this view, the universe is not a cold, dead place. It is a place buzzing with quiet attention. We are the new kids in a very old school, and the seniors are watching from the shadows, waiting to see if we will pass the test. It is a feeling of grandeur, of mystery, and ultimately of hope. We are part of something infinite, and we are currently being introduced to the network one data point at a time. The Great Traveller. The object we came to call 3Y Atlas has finally moved past the boundaries of what we can clearly see. It is no longer the bright, confusing spark that ignited headlines and kept telescopes awake for months. It has slipped past the orbit of Neptune, gliding silently into the freezing dark of the Kuiper Belt. The signal, once a steady rhythm that baffled our best minds, has faded into a whisper and then into silence. It has returned to the deep velvet void from which it came. As it drifts away, moving at speeds we can barely comprehend, it takes its secrets with it. It does not leave us with a map or a blueprint or a clear message. It leaves us only with the echo of its passing. We watched it spin, we watched it accelerate, and now we watch it disappear. The monitors in the observatories are quieting down. The frantic energy of discovery is settling into a calm, reflective hum. The red shift of its light tells us it is leaving, stretching out into the distance, never to return. There is a profound beauty in this departure. For a brief moment in the history of our species, we all looked in the same direction. We paused our daily lives, our small worries, and our terrestrial arguments to stare at a single point of light moving against the canvas of the night. Now that point of light is gone, swallowed by the shadow of the galaxy, but it has left something behind. It has left us with a new for you feeling, a legacy of mystery that is far more valuable than any data point. The lesson of Atlas is not about what we learned, but about what we realized we do not know. Before this visitor arrived, we thought we had the solar system figured out. We thought we understood the rules of the road. But the universe in its infinite grace sent us a reminder of our own smallness. It showed us that there are still wonders hidden in the dark waiting to surprise us. This is a comforting thought. If we knew everything, if there were no more secrets, the universe would feel small and closed. But because Atlas exists, because it came and went without explaining itself, we know that the cosmos is still vast, wild, and filled with potential. We have learned to accept that we don't need to have all the answers right now. It is okay to simply witness. It is okay to let the mystery be a mystery. Take a moment now to feel that shift in perspective. Let the heavy weight of the need to know lift off your shoulders. You do not need to solve the puzzle of your life tonight. You do not need to analyze the day that has just passed, just as the scientists no longer need to analyze every pixel of Atlas. The work is done. The event is over. What remains is the peace of the aftermath. Imagine yourself standing in a wide open field at night. The grass is cool and soft beneath you. The air is still, carrying the scent of night-blooming flowers and fresh earth. Above you, the sky is not just a ceiling, but a deep, infinite ocean of stars. Without the distraction of the wandering traveller, the sky has returned to its timeless state. The constellations are exactly where they have always been, steady and reassuring. As you look up in your mind's eye, you can feel the sheer scale of what is out there. The distance between the stars is measured in light years, a space so quiet and so large that it swallows all noise and all stress. In the face of such vastness, your own worries seem to shrink. They become small, manageable things drifting away like dust motes in a sunbeam. You are part of this vastness. You are made of the same carbon and stardust that make up the comets and the nebulas. You belong to this quiet dark. Let your breathing slow down to match the rhythm of the cosmos. Inhale slowly, imagining you are drawing in the cool, calm energy of the night sky. Exhale, completely releasing any tension, letting it float up and away, dissipating into the upper atmosphere. With every breath you become heavier, sinking deeper into your bed just as a stone settles into the soft sand of a riverbed. Think of Atlas again now, just a silent rock tumbling through the dark. It is peaceful out there. There is no wind to push against it, no sound to disturb it. It is floating in a state of perfect suspension. Imagine that you are floating with it. You are weightless. The gravity of the earth is holding you safely, but your spirit is light, drifting on the currents of sleep. The universe is singing a lullaby, but it is not a song of words or melody. It is the lullaby of silence. It is the low, steady thrum of existence. It is the sound of the planets slowly turning on their axes. It is the sound of the tide shifting in the moonlight. This silence wraps around you like a heavy, warm blanket. It covers your feet, your legs, your torso, reaching all the way up to your shoulders, tucking you in. Your eyelids are heavy now. They feel as though they are made of lead. To keep them open would take too much effort, and there is nothing left to see tonight. The show is over. The lights are dimming. The universe is closing its great eye, and it is time for you to close yours. As you drift deeper, remember the promise that the night sky offers. The universe will still be there when you wake up. The stars will continue to burn, the planets will continue to spin, and the galaxies will continue their slow dance through the void. You do not need to watch them. You do not need to guard them. They are waiting for you. They are patient. Tonight's sleep comes to you not as a shutting down, but as a journey. You are an explorer just like the traveller Atlas, but you are not travelling through cold space. You are travelling into the warm, rich inner world of your dreams. In this world, time moves differently. In this world, you are free to float, to fly, to revisit memories, or to simply rest in the nothingness. Allow your mind to let go of the last tether to the waking world. Imagine the rope that holds you to the dock of the day is gently untied. You are a boat drifting out onto a calm, glass-like lake. The water reflects the stars above so that you are floating between two skies. Above you is the infinite, below you is the infinite. You are suspended in the center of peace. The darkness behind your eyes is not empty. It is velvety and rich. It is a canvas waiting for dreams. Let the images come and go. Soft colors, gentle faces, quiet landscapes. Let them pass by like clouds. Do not hold on to them. Just watch them drift. Everything is slowing down. Your heart rate is calm and steady, a slow drum beating a rhythm of rest. Your muscles are completely relaxed, melting into the mattress. From the tips of your toes to the top of your head, a wave of relaxation washes over you. It is warm like sunlight, yet cool like the moon. It soothes every nerve, quiets every thought. The mystery of the universe is no longer a question to be answered. It is a pillow to rest your head upon. The fact that we do not know everything is a gift. It means there is always more to dream about. It means the story never truly ends. And so we bid farewell to the traveller Atlas. We thank it for the visit. We thank it for making us look up. And now we let it go. We let it drift into the shadows just as you are drifting now. Deeper and deeper, quieter and quieter. The stars are your nightlights. The silence is your song. The universe is holding you. You are safe, you are small, but you are infinite. Sleep is approaching like a soft fog rolling in from the edges of your mind. It covers everything in a soft white mist. The edges of the room are blurring. The sounds of the house are fading away. There is only you and the gentle dark. Let go, drift, float. Good night, traveller. Good night, watcher. The stars will watch over you now.